Hey guys, today we're going to do 4-9 quadratic systems. So you will be able to graph systems, solve graphs of systems of linear equations and quadratic equations, or quadratic and quadratic equations. We can solve systems involving both of these using similar methods that we did to solving systems of linear equations. So still, once again, the points where the graphs hit the equations, where the equations intersect each other, is where we have our solutions. So we can have two solutions. Like so in our first graph, we can have one solution where our vertex is on the line, or we can have no solutions where the two graphs do not intersect. When we are solving a linear quadratic system by graphing, we want to know where the two graphs intersect. So first, to save time, the graph is already up there, but we would have to graph the first quadratic and the linear equations. And the question says, which numbers are y values of the solutions of the system of equations? So we have our points, 0, 6, and 4, 10. Those are our solutions to our system. The y values are 6 and 10. Therefore, our answer would be D. You could check our solutions by plugging them into our equations in the system. So 6 could be equal to the opposite of 0 squared plus 5 times 0 plus 6. So 6 is equal to 0. Check. And you would keep going with 4 and 10 is equal to the opposite of 4 squared plus 5 times 4 plus 6. And 10 is equal to 10. Check. You would then also check in the second equation, but for time's sake, I'm going to keep going. We can also solve a linear quadratic system by using substitution. We see that y is equal to something and y is equal to something else. So if we set them both equal to each other, so x plus 3 is equal to negative x squared minus x plus 6. I can now solve this quadratic by moving putting this in standard form and factoring. So I'm going to add x squared, add x, and subtract 6. So I'm left with x squared plus 2x minus 3 equals 0. I need to know what multiplies to negative 3 and adds to 2. I'm going to say 3 and negative 1. Therefore, I have x plus 3 times x minus 1 is equal to 0. So my two solutions would be x plus 3 equals 0. X is equal to negative 3. X minus 1 equals 0. X is equal to 1 would be my two solutions. You can solve a quadratic system using the same methods we did for solving linear quadratic systems as well. So you can graph both of the two quadratics and see where they intersect, or you can use substitution and set them equal to each other. So I'm going to do substitution. I'm going to once again put it in standard form. Get 0 is equal to 2x squared plus 8x. Those cancel. Now I can factor this by taking out a 2x times x plus 4 equals 0. So 2x equals 0 and x plus 4 equals 0. I set both of my factors equal to 0. Solve for x. X is equal to 0. And x is equal to negative 4. Solving a quadratic system of inequalities is once again going to be using the same methods we did while we were solving systems of linear inequalities. We're going to graph the first and shade, graph the second quadratic and shade. The region they intersect, which would be here in the middle, would be our solution to this system of inequalities. Try these on your own and you're good for solving quadratic systems.